Hello, welcome everybody. I am Mark McLean, Sparky Mark. How are you guys doing? Hi Ebne, how are you? I can see you've written into the chat. Please let me know in the chat how you guys are doing, and also let me know where in the world you are located. Now I know you've just done a little poll on where you are located, but let me know a little bit more specifically. So so I can see Ebne, you're saying that you're in New York. Fantastic. I am in London in England, and Padma in San Francisco, Alexander in New York City as well, Aaron EST USA, fantastic, brilliant, lovely. And as I said, I'm in London in England. Now I hope you're all well and ready to do some fun science. Today we are going to be looking at the polarized light set, which is a lot of fun. Liam in Minneapolis, fantastic. Now, as ever with these sessions, if your name is different than your actual name, so say for example you're using a parent or a friend's Zoom account or something like that, please do let us know in the chat. Say change my name to. So say for example there are two of you there. Now I can see from the poll there's a vast majority of people from the USA, fantastic, and a few from Europe as well, lovely, brilliant. And Rez, who's in the chat, should be able to change your name for you. So fantastic. Now, okay, we'll get started in just a second, but just before we do that, I want to introduce you to two important individuals. The first is Rez, that's R-E-Z, and Rez is in the chat, so you guys can send messages that both he and I can see, and he's the one who's being wonderful and changing your names for you, so that so we can see who. So Levi and Lalia from Lowell, Michigan, fantastic, brilliant. Perfect. Now, also, as I say, I'll get onto the second individual in just a second, just to say that, so you can message us, but so that you're not bombarded with hundreds and hundreds of messages, only we can see your messages, but I'll do my best to read out your messages and your questions, which I really, really love. Fantastic. And I can see Aaron is saying hi to Rez. So fantastic. So hi Rez, and we're very fortunate to have Rez here. So if you have any problems with your audio or video, please do let him know. And also if there's any questions that I've missed for some reason or something like that, then please do let him know as well. Now that's one important individual. The second important individual is this chap here. Hey Owly, how you doing, buddy? It's Owly, everybody. What's occurring? Fantastic. You're having a good day? Now, Owly is very, very excited by this because he loves the polarized light set. What is it? You love the pretty colors, and yeah, I know, it's awesome. It's a really, really cool set. I have to say that the MEL Science guys who developed this one, this is a particularly cool one. Now, many of them, many of the bits of this set become easier to see when you actually use the glasses, and so I'm going to try and replicate that using with my other camera here, and we'll see how we go. Now, again, this is completely live, so if you have any questions or any comments, we'll do our best to answer them. For anyone who hasn't met Owly before, he is my... Oh no, I definitely wasn't going to say... he's my stuffed toy owl, because Owly doesn't like being called a stuffed toy owl. He thinks he's a real owl. So yeah, no, definitely. Yeah, you're definitely a real owl. Uh-huh. Well, okay, now, I mean, I know that my voice sounds like I was being sarcastic, and I'm sort of inferring you're not really an owl. But no, you're definitely a real owl that lives in a house with a human being in London doing science experiments online. So yeah, cool, thanks. All right, you're excited? Yes. All right, will you come back and help with some of the experiments? Fantastic, thanks, buddy. Okay, so as I said, Owly is definitely not a stuffed toy owl, and I use him on many of the early demonstrations, and he's so popular now that I think if I ever did a session without him, you guys would be very annoyed. So there we go, there's Owly, fantastic. Brilliant. Yes, he is if you give him a soul, says Ebne. Yeah, fantastic. Brilliant. Good. And see lots of people commenting on Owly. Fantastic. I know he's very, very cute. All right. So as I said, we are going to be doing the polarized light set today. And the only thing you're going to need that's additional to the set is a pair of scissors, but please obviously be careful with those. And if you've got a parent or a guardian around, a suitable, responsible adult, fantastic, we're going to be doing this. And it's usually, the sets are useful if you know, I think are more fun if you share them with other family members anyway, which is pretty cool. Now, I have to say, I'm loving these MEL Science Physics kits. They're really, really cool. And I think that, as I said before, that the people who develop them, the actual guys, they must have a lot of fun developing these sets, because they are very, very fun. Okay, brilliant. Now, I'm just going to do a quick question for you guys. Have you got the set, first of all? Will you be doing it with me? So Aaron, Alex, Alexander, Angel, Chelsea, Ebne, Hanson, Levi and Lila, yeah, Misha, Phoebe, John, and Wiseheart, Ria, Vishay, Vaznath. Have you guys got the set? So yes and yes and yes, you got the set. Fantastic. And hopefully you're going to be doing it with me. So for anyone who didn't for one reason or another, then obviously I'll make sure you can see everything. But please do the set with me. I think it makes it a lot more fun, a lot more interesting, and have a look at the really, really pretty colors. It is a very, very cool set, I must say. And obviously I'll do my best to sort of show as much as I can through camera, but if you can't see something for some reason, please let me know in the chat and I'll move things around and try and make it work. Brilliant. Right, so the first thing I'm going to do is open the set. So all we have to do is just push sideways and we just slide the box out, and we can put this away to the side. Now, inside on the back of the box, we have all of the what the set contains. Now it says here you're going to need some scissors and a smartphone. The smartphone is quite useful if we're going to sort of use it for things like the torch and things like that and stuff. So if you have one of those, then that's useful too. All right, fantastic. Great, but I'm going to open up the box. Now the way we do this is there's a little tag at the bottom here, and we just pull upwards and we should be opening the box there. Now what I'm going to do is I'm going to switch the view here so we can see what is going on inside. Now things might move around a little bit, but we've got the instructions here. Now Ali calls them the destructions. Hopefully we're not going to be destroying anything. And we're going to be doing the first one, so the Polarization 101, we'll be doing that first. But we've also got number 2, which we'll do afterwards. And also number 3 is hidden all the way under here. Here it is. There's my number 3. Okay, so I'm going to pop these over to one side. And then I'm also going to get all of the packets out, so we have everything ready. And they are labeled 1, 2, and 3, so you know which one goes with which set. So if we just lay everything over to one side, then it's easy to kind of see, you know, be able to find everything. Now there is also a bonus experiment as well that comes with part of the set. And it's actually pretty cool. So all you have to do is just on the back, open up the MEL Science Kit and scan the MEL code on the card. Okay, and that's there's a little bonus experiment. Now, fantastic, brilliant. Now we've also got these bits here, but we'll go into what we're using those for in just a minute. Okay, brilliant. So, right, so we're going to be doing this set, and I think most of you guys are going to be doing it too, which is fantastic. Have you been able to get everything out? What app are we using for streams? We're using OBS today for the streams. Right, great, fantastic, great. Okay, so the key, now we'll go through some key concepts so you understand essentially what's going on here. Now light can be thought of as a stream of tiny particles. So the light that is landing on me here, so I have a light here, and that's kind of, and I have another light here, and also got another light here in the studio. But lots of lights. But light itself can be thought as a stream of tiny particles called photons. Okay, so light can be thought of as a stream of tiny particles called photons. Now a light bulb can produce more than 1 billion photons every second. So just a normal light bulb can produce more than 1 billion photons every second. Now now the more photons that reach your eyes, the brighter the light seems. So if there's very little photons, it's kind of like a stream of water here. if lots of photons arrive at your eyes, then we see brighter light, and less photons means darker light. So in fact, I've got control, here we go, over the lights here. And if I turn off the light, less photons. So essentially what happens is the light travels in straight lines, bounces off me and goes towards the camera where you guys can see me. If I turn them off, it's much faster, there's much less photons. But I'm going to turn them on again. Owlie, hope you weren't scared of the dark. Owlie there? No, you're a nocturnal animal, so you prefer the dark. Okay, yeah, so actually Owlie prefers the dark, he said. So yes, because he's a nocturnal animal. Okay, cool. Thanks, buddy. All right, brilliant. So we're going to get going now. So let's get them out. So I'm going to take out set 1 here. Okay, so I'm going to switch so you can see the set 1. Okay, and I'm just going to grab the instructions. Now, first of all, what we're going to be doing is this. Now, there are dark films inside the set. So let me grab those out. Okay, and they're known as polarization filters. Okay, they're known as polarization filters. Now, as I said, light can be thought of as a stream of tiny particles called photons. Now, the key thing here, before we do this next part, is to understand that photons have their own color. Okay, so they're different colors, of course. That's how we see different colors. So these ones here are green, and these ones here are sort of red and things. Essentially, they have their own color, but they also have an attribute called polarization. Okay. Now, this can be almost thought about at the angle at which they are tilted. Okay, so they can be sort of angled. Okay, now the problem is we can't see this with our eyes. We can't see the angle that they come in at, but we can. There are ways that we can see which angle they're coming in at. So as I said, these little photons of light, the more of them there are, the brighter they get. Now have a look at this, which is actually quite a fun experiment. So what I'll do here is I'm just going to grab 2 of these dark films. Okay, now the thing is you can see through them. Okay, so have a look at this. You can see through, and here's my fingers. Are you happy with that? You can see my fingers. Now have a look at this. If I take another one, okay, look at that. It gets a bit darker, but that's fine. But watch this. Okay, what I'm going to do is I'm going to rotate one of them. Now look at what happens. Okay, look at what happens. Look at this. So I rotate it back. There. Can you see how it becomes darker? Perfect. Thanks, Rez. Okay, brilliant. Right? So what's happening here? Well, the thing is that this polarization filter is only allowing light through at a particular angle. Okay, so it's only a particular angle is able to get through. Okay, now this polarization filter here does the same thing. It will only allow light through also at a particular angle. But if we have them if they're both the same, that's absolutely fine. But if I rotate this, now it won't allow any light through because it's not allowing either of those angles. So that way you cannot see my hand through there, which is very, very cool. Now, have you been able to see that at home, and is it clear for you? Were you able to see what's going on there? Okay, right. So let me know in the chat. Fantastic, fantastic, Alexander. Thank you very much. Thanks, Aaron. Brilliant. Okay, now within the set, okay, there are some small bits. Here we go, some small bits of wood, and we're going to get some of those pieces out, and we're going to build a stand for the smartphone. Okay, so what we're going to do is there are these 2 pieces here that kind of look a little bit like sledges. Okay, and we've got this piece here. Okay, now what we're going to do with these, let me just double check my focus. There we go. Sometimes my camera isn't the best at focusing. There we go. Pretty good. All right. So what we then do is we place the 2 little sledges like this, and we can actually slide this holder, this support, onto the little base parts here. Okay. So let me know if you have any problem with this at home. But what you do is you slide both of those into the support that holds them together. You just need, and you might need a little bit of help from an adult, but if not, that's okay. Right, so that's fine. So what we've got here is this is a little support, and this is useful for holding our smartphone. Okay, so what I'm going to do here is there we go. It should hopefully hold my smartphone nice and easy like this. Okay, and what it will then do is it acts just as a support for our torch. Now the thing we're actually going to be using here is the torch on the phone, okay, on the cell phone, on the mobile phone there, okay, which is absolutely fine. Now I'll get onto that in just a second. Let me just turn off my torch and save some battery. Okay, I'm going to pop that here. Now what I'm going to do is this. We are going to get some foil. Okay, so within this first set here, we've got the foil. Okay, and there's some foil here. Okay, but also before we do that, should also be, here we go, let me just grab these out. Perfect. A little piece of black card. So I'm going to put my foil just here and the little piece of black card here. And there is a protective film that actually protects our little piece of plastic, our see-through plastic. So we just peel that off here. Okay, so we just peel this off, the protective film. There we go. Now we place that, and in fact, I think there should be a protective film on both sides. Yeah, there's a blue one and a normal transparent one. Okay, and so what we do is we then place this piece of plastic onto this black piece of card. The reason we're doing that is we are actually going to create a form of a mirror. Okay, which should reflect light nice and easily. Then what I do is I take my cell phone camera and I turn that on. Okay, I'm going to place it here. And what I'm going to do is if I can tilt it at just the right angle, you should, here we go, you should be able to see. There we go. I've not done a very good job. There we go. Now, hopefully you can see. So this is the cell phone here, and you can see the my mobile telephone, and you can see the light reflected in here. Okay. So let me place that there. You should be able to see the light reflected. Now, obviously, I'm not just having to do this for myself, but I'm having to make sure I do this for the camera so you guys can see. Okay, but hopefully you can see that it is nice and reflected there. Okay. All right, now what I might do, I might even dim the lights just a little bit. Here we go. So I'm going to dim the lights a little bit just so we, there we go. So it's a little bit clearer. There we go. Okay, right, so that's what's happening here. Now what I'm going to do, okay, is I'm going to take one of my polarization filters that only allows the light through at one angle. And what I'm going to do is I'm going to have a look at the light. Now, can you see that it doesn't dim a huge amount? Okay, so what actually happens is as I move this in front, look at what happens to the light. But have a look at this. If I rotate this around, the light actually becomes much less bright. Now, what I'm going to do is if I turn off the lights, it makes it much, much clearer here. Okay, so look how bright it is here. But if I rotate this around, look at it becomes significantly darker. Okay, so let me make sure that that's nice and bright. And if I rotate it round, look at that, significantly darker, brighter, darker, brighter, darker. There we go. Now, as I say, please, thank you very much for being so patient with me, I have to say, because obviously I'm having to make sure that you guys can see this at home. Now, what is going on there? Why is it getting lighter and darker and lighter and darker? Well, the reason is that as light reflects off plastic objects, off this particular plastic object, what actually happens is it actually becomes polarized. So this plastic thing here is polarizing. Now, what do I mean by polarizing? Remember I said that light photons, okay, so photons of light can either have color, okay, they can be different colors, but they can also have an angle at which they travel at, okay? Now, there is a nice little diagram on the sheet here, okay? So what I'll do is I'll just show you here, okay? So what we can see here is if this is the source of light, do you see these tall pieces, there we go, these little tall sausages, right? Those represent light that's standing upright. But you can see that some of them are sideways here. So do have a look at your set and have a look at that. Now what's happening is this thing here, this grey thing here is our polarization filter. What's happening is it's only allowing light through that is the standy up ones, which means all of these guys that are side to side are not being allowed through, okay? But what's going on with our set here is that when light reflects off this plastic object here, okay, it's actually being polarized. So only light in a certain direction, that certain angle essentially is being allowed through. What then happens is if we tilt our polarization filter, it actually reduces the light even more. But if our polarization filter is allowing it through in the same angle, it doesn't get any dimmer. Now, it's a nice demonstration, okay, but we're going to be going into more of this. So if you're still not 100% sure what's going on with polarization, don't worry, I'm going to be doing more of it. But I just wanted to make sure that I kind of had demonstrated. Now, I'm just going to do a poll for you guys. Light can be thought of as, so Rez, I think, sorry, I didn't give you any notice on that at all, but let's have a think. So light can be thought of as, okay, a type of cat that likes sleeping, a stream of tiny particles called photons, or a type of sound wave that we can see, or is it a type of wind that blows in our eyes? What can we think of as light? How can we think of light? Now, as I say, you don't have to answer these, don't worry. Now, I won't see what you answer, so don't worry about putting a right or wrong answer, but it's just more just to kind of get you guys going, check that you're awake, check that you're with me on this. I can see almost all of you guys have clicked it. Just one more to go from the sounds of it. Perfect. Everyone has answered. Thank you very much. So let's have a look. I'm going to share the results. I can see that 93% of you, almost all of you, have said that light can be thought of as a stream of tiny particles called photons, and they're absolutely right. I see someone put a type of wind that blows their eyes. Remember, I don't know who clicked what. It could be, I guess. The thing about light, though, remember, it is this tiny stream of little photons that hit our eyes. So I guess it's a light wind, maybe. But thank you very much. By the way, whether you got the right or wrong, I don't need you to get the right answers. This is just us kind of, as I say, one of the best, I talk about this a lot, is one of the best ways of learning is just trying things out. So thank you very much for everyone who answered. That's all of you guys. Amazing. Great responses. Okay, now, let me quickly go on to the third concept here. The first concept is that light travels as a stream of little things called particles called photons. The second is that photons can kind of come in at an angle, and that's known as its polarization. And a polarization filter will actually cut off certain angles. It says, sorry, you're at the wrong angle, light. The third concept is that sunlight and light bulbs give out light at all different polarizations, so all different lights. So the sun gives off light that's all different directions. It doesn't care. Our polarization filter allows only certain light through, okay, that's at a particular angle. Do you remember the diagram with the standy up bits of light and the side to side? So if your light comes in like this and the filter's like this, it will just pass right through. But if the light's coming at this angle, okay, and the slits on this, now there are tiny, tiny little slits here that you can't see, but under a microscope you can. The slits are like this. Any light traveling at this angle will not get through. So now filters can be made to allow only one polarization filter through. Okay, all right, fantastic. Now let me just let's go on to the second experiment. So or the second part of this one. Now that is using our little silver foil here. Okay, so this will be listed as part 4, but let's have a look at this. So what I'm going to do is I'll just turn my my torch on again, and let's have a look here. So what we're going to do is we're going to take the silver foil here, and we can see that it is doing some good reflecting of the light. Can you see that? That's definitely reflecting the light that's coming from the if I cover the, there we go, fantastic, good. Now what I'm going to do here is I'm going to take the polarization filter and I'm going to rotate it, and let's see what happens to the light. Now the answer is nothing happens. There's no change there. Okay, there is no change. The reason is that when the light comes out at all directions, the silver foil does not polarize it, meaning that it doesn't really matter what angle this is coming at. Now, let me just show you again, just to make sure that it's not a trick. We can see this with this here. It definitely becomes darker and lighter. You can see as I rotate this, the light becomes lighter and darker. Again, much easier if you have a look through the, there we go. I think it's slightly out of focus there. Sorry about that. I think it's just not quite ready with the dark images, but there we go. Now, hopefully that should focus in just a second. Okay, perfect. So as I said to you, the main thing here to understand is that light comes in at different angles, and these polarization filters can have an effect on them. But if light bounces off something like this, some form of mirrored object, it doesn't polarize, meaning that there's no difference. Okay, but if it bounces off this plastic, it does. Now, the other thing that also happens is that's not just plastic. Things like glass and also water as well. Glass and water can both have a big effect in the sense that it will polarize them, meaning that we see lots of reflection on water. But if we use a polarizing filter, that reflection will actually disappear. And I'll talk about that in just a minute here. But just before we carry on, and we're going to do the next experiments, the 2 and 3, which are, by the way, really cool. And these are Owlie's really, really favorites. I know we're just going over the science here a little bit. What does a polarization filter do to light? So we just do a little poll. What does a polarization filter do to light? Okay. Now, does it A, only allow photons with one type of polarization through? I'm not sure if it's coming. Or does it allow all types of photons through? Does it stop things smelling bad, or it doesn't do anything? So remember, this is my polarization filter here. Does it only allow photons with one type of polarization? That's the angle they're coming in at. Or does it allow everything through? Or does it stop things smelling bad, or it doesn't do anything? Okay, now remember, I don't need you to get the right answer here. That's not important. It's just giving it a go. And in fact, sometimes putting an answer and being not sure and just having a go will actually allow us to learn a lot better as well. Our brain is much more likely to hold on to memory. So sometimes just having a go and getting it wrong means our brain will actually hold on to that information much more efficiently than if I just told you the answer. So I can see that pretty much everyone has answered. Cool, just one more person, but you don't have to, it's okay. All right, I'm going to end it there. So let's have a look. I'll share the results with you. Now I can see that 92, remember I don't know who's answered, 92% of you have said that a polarization filter, okay, what does it do? It only allows, and this is absolutely right, it only allows photons, bits of light, through with one type of polarization, light at only one angle. That's what happens, okay? Now, so that's it. That's well done. Thank you very much for everyone who answered. Whether you got it right or wrong, doesn't matter. Main part is that you are participating. And thank you very much. I had to say, you guys can see Owlie and I. Yeah, Owlie, that's right. They can see us. Yeah, no, they're just there in the... Well, no, they're not in the camera. They're at home. They're actually all over the world. In fact, there's a lot of people in America and some in Europe as well. No, I haven't put America into the camp. Do you know what? I think I haven't quite explained to Owlie how you guys are seeing us. But the thing is, you can see us. So welcome to our home in London. But we can't see you. And so we love the fact that you post questions and that you post your comments and you're also answering the polls. So thank you very much. Yes, Ali says I need to stop talking and get on with some awesome experiment. Okay, I'll get on with the experiments. He loves these ones because now we're going to get into the really, really colourful ones. So as we saw, the foil didn't polarize the light, so the polarization filter makes no difference, but it did polarize, the plastic did. Now again, in the same principle, this polarization filter is polarizing the light, it's only allowing at one angle. If I put this in front of it, it's fine, they're both in the right way, but if I tilt this, it actually goes dark. Pretty cool. Okay, let's get going with the next part. Oh, I need to remember to turn off the torch on my mobile telephone. Cool, we're on to part 2 now. Now we're going to be looking at color stress patterns. Okay, and this is the colorful part, which I really, really enjoy. Now the concept for this is that objects change their optical properties. They change the way that they look, okay, when they're put under stress. That means if you bend something that is see-through or transparent, actually when you put it under stress, it will actually change its optical properties. It changes the way it looks. Now the molecules, what happens is if you stretch an object, generally the molecules will align themselves in that stretch. So if I take, you know, a piece of metal or something like this, even now I'm not strong enough to do this, but this is just an iron nail. If I pull the nail, what will happen is with enough force, the atoms themselves inside it, everything's made of atoms, okay? They're so tiny we can't see them even under a microscope. But the atoms will line themselves in straight lines based on that stress. And now that will only allow light through in one direction. Now, the thing is, obviously with a nail, it doesn't allow any light through, but we're going to have a look at some cool objects that do allow light through and why this is important. But remember, different colored photons are affected differently when they pass through the material. So do you remember I said photons can also have different angles, but they can also have different colors. And so they will be affected differently, which means that we get these wonderful color patterns. Now, why is this useful? Well, actually, it means that we can build objects like bridges and models of large objects, and we can test using these awesome polarization glasses here. We can actually test how the stresses and strains work, which is really useful for building buildings, okay, and lots of other objects. So if we get all of this stuff out for set 2, and what we're going to do here is we're going to build our polarization filter, standing filter. So what we're going to need is this piece of wood here, if you want to get that out, and we're going to also need the legs to go on it. Okay, so those are the legs, and what we do is we take the legs and we place them onto, there we go, so we just place them on here, okay, just like this, and they make sure they're going the same direction, and all you have to then do is just give it a little push, okay, it might need a little bit of wiggling just to get them on there. There we go, there we go, I've got them on there, okay, fantastic. Now what we can do is on the back of this, okay, now as I say, I put the legs on there already, but you don't necessarily have to put them on straight away. There's a wonderful thing on the back here, so what I'm going to do quickly is grab this. Now there's a little cardboard holder here, okay. Now what we do is this, we actually take some tape, so you should have some sticky tape that comes with the set here. I'm going to take some tape, and what I'm going to do here is this. We bring these together and we make sure that the arrow is pointing upwards. Now I'm just going to make sure I've made a bit of Ali's telling me that I made a bit of a mess. Yes, sorry about that. So I'm going to take this, and let me grab my scissors as well, and I'm going to be very, very careful with my fingers. I just make a little cut there. Okay, then what we do is we place this onto the side here, the side, so not where the arrow is. We just want to place it onto the side here, the sticky tape, and we just fold it over. We fold the sellotape, the sticky tape over there, so it forms, so it holds those two together. There we go, just making sure I show the camera. Then we want to do that on the other side as well. Okay, so I'm just going to take a little bit more tape, sometimes called Scotch tape, but it depends on whatever you call it. We're just using some of this sticky tape, and so let me show you again what we do. We take a small amount, pop it onto the edge here, okay, and then we fold this over so it holds those sides together. Now the top part where with the triangle should still be, with the red triangle should still be open. Then what we're going to do is, you see these little yellow sticky pads? If you peel them off very carefully, now you peel them off very carefully. There we go. Now it seems that some of my sticky tape covered that, but that's okay, that's fine. And then I'm going to do the bottom one as well. What I'm going to do is I'm going to stick this to the back of my sort of fake screen here. Okay, so this is the back part, is where the long legs are. Now, if you haven't stuck the legs on, that's okay yet, don't worry. But what I'm going to do is stick this here and just make sure that the white part goes around the hole there. And make sure the red triangle is facing up. Now, how are you guys getting on with this? I know it's a little bit fiddly, but you can get someone to help you. But don't worry, even if you're not kept up with me, that's okay, because there's not much more to do. All we have to do is then turn it over, and we're going to add our MEL physics sticker to the front there. Now that is optional, but I think it looks very, very smart. There we go. So MEL Physics one there. Cool. And within the set, there will also be a piece of white paper, and I'm going to just place it onto the white paper there. Okay. Fantastic. Now, how are you guys getting on with this? Brilliant. Now, what we're going to do next is I'm going to take one of my polarization filters, okay, and I'm going to place this into the back here, okay, so into the back, and you can actually just slide it. There we go. You should be able to slide this. Now, we just need to do just inside there. There we go. You should be able to slide this just into the viewer there. Okay, so that's that there. I'm just sliding that one in there. Okay, perfect. Okay, so I can see Kira's saying not very fast. That's okay, don't worry. But as I say, it takes a little bit of time to make this, and I'll obviously let you carry on in your own time too. But all we're doing is you just need to make sure you put the 2 wooden legs on there, and then you stick this white piece of card around here, and that becomes the holder that we can then put our polarization filters in. Okay, and I can see Chelsea said you already made it. Fantastic, well done, brilliant. So anyone who needs any help, let us know in the chat, and we can, but hopefully you should be okay, and I will keep going. Now what I'm going to do next here is this. We are going to then look through the glasses. Okay, right, so I'm going to look through the glasses here. So if we get the glasses out of the set, I should be able to pop my glasses on so I can see some cool stuff happening. Okay, fantastic, brilliant. Now the problem is that you guys, when you look through the camera here, so you're looking through this camera here, don't have the glasses. So what I'm going to do is I'm going to tape these glasses here, okay, over. Okay, I'm going to take them over the camera here so that you can see what I would be seeing at home. So let me just quickly do that. So it's equivalent, I'm giving you the glasses so you can see, because it doesn't work if you don't use the polarization glasses. So what I'm going to do is, now this was actually Owlie's idea, because I said, well, how can I let everyone at home be able to see what is going on? Well, he said, why don't you put the glasses onto the camera? He's a very clever owl. There we go. Good thing. There we go. Perfect. So I've just taped the glasses on there. Now at the moment they haven't stayed on, so I'm just going to do a tiny bit more tape, but this hopefully gives you guys enough time at home to catch up. Good, and you're good. Fantastic, Kira. Fantastic, brilliant. Okay, good. Right, so let's keep going with Owlie's suggestion. I'm going to tape the glasses here. I'm just going to tape them onto the camera. Okay, so now that's you guys looking through the glasses. Now I'm going to prove it to you, because have a look at this. This is the polarization filter, but watch, if I turn it sideways, we can see that it just is a bit. So you're actually, this is what you should be able to see at home for anyone who's participating in this. Okay, look at that. Isn't that incredible? It just suddenly becomes complete back. The reason is the glasses are polarization filters too, so they're only allowing light through at one particular angle in one direction. Well, this here, the moment I turn this, now all of the light that would be bouncing off this, none of it can get through. Okay, so look at this. You can see my hands, and then suddenly, magic, which is pretty cool. I like this one. I know Owlie does too. Right, so what we're going to do now is this. We have a look through this. Now, if you've got the glasses on right and we've got the right angle for this, we should put this on so you can't see anything. Now what I'm going to do, okay, now if you can see through this, what you need to do is you need to take your polarization filter out. Okay, we just take this out and rotate it round. Now what I'm going to do here is I'm going to take a plastic bag like this, watch this, and I'm going to stretch it. And what I'll do is I'm going to place this little spoon here. But have a look at this. Now we can see some very cool, look at this. Now can you see you cannot see the spoon through here, right? You can't see the spoon. Now this is what I love about this experiment, and I have to say Owlie does too, is that you cannot see the spoon. Look at this. I've got this, this Here we go, transparent spoon there, the plastic spoon behind. You cannot see it, but if I take this little plastic bag here, watch this, and I rotate it, okay, it starts to create some pretty interesting colours. And I don't know if you can see this, but can you see the spoon there? And there's my finger as well that's magically appeared. But look, no, you can't see my finger, but now you can, okay? And so what I'm going to do here is I'm going to stretch the plastic bag in different directions, and we start to see some pretty interesting colours here as well. There we go. Now I think there might be a little bit too much light on that one, so what I'll do is kind of, there we go, and look at those pretty colours. Can you see the blues and the oranges? Now they're not there, this is just a normal plastic bag, okay? But when I start to put it under stress, look at that, you see the oranges and the pretty blues. Now what colours can you guys see at home through your glasses there? What colours can you see? Please let me know in the chat. There should be no right or wrong colours, but let me know if you can see them. Okay, so that's a pretty cool one. Now here's another one. I've got this little Petri dish here. Okay, I've got this little Petri dish. Now have a look at this. Isn't this incredible? I've already given you a look at that. So let me move all this away. There we go. Sorry, a little bit. There we go. Watch this. Look at the colours. It's very, very cool. Really cool. Now I can see that Levi and Lila, is it? Blue, orange, brown, fantastic. Kira said orange, blue, purple, fantastic. Look at these colours. Now we can see these reds and greens, and is even a yellow there? I don't know if you can see the yellow. What I'll do is I'll brighten my screen a little bit so it makes it even clearer for me to see, and I'll just turn off that light. Look at these colours here. Look, there's sort of purples and blues and yellows, which is actually incredible. And by the way, we can actually see that this Petri dish here, so just looking at it, we can see that just this area here. Now, if I lift this up, okay, so if I just move this over to the side, the Petri dish is completely clear. There's nothing, there looks nothing wrong with it at all, okay? But when I place this here, we can actually see that there's an area of the Petri dish that's actually under stress here, okay? So if I just start to bend that as well, we can see that it's starting to, now I'm not sure what's going on with the focus there, sorry about that. There we go, but you can see all those beautiful colours there. Fantastic. All right, great. So I'll make sure it's light enough, there we go. And I see Chelsea said blue, purple, orange. Is that violet that you've said, Ria? Vibral, yeah, right. Oh, violet, indigo, blue, green, yellow, orange, fantastic, and red. Brilliant, I see. Okay, brilliant. I see cyan, says Kira. Brilliant. So some wonderful, wonderful colours. Now, I have to say, I love these experiments because, you know, we just had a little plastic bag. I mean, great, little plastic bag. But what's incredible about it is that we can start to, when we put it under stress, we start to pull it, we see these colours changing. And so that actually shows us. So as I said, the concept 5 is that objects will change their properties, change their colour properties when put under stress, when we put them under a force or we pull them or push them. Now, it's because the molecules that make up these objects here, when we stretch them, the molecules will straighten in the direction that they're being stretched. Now, different coloured photons are affected differently as they pass through the material. So the blue ones will be affected differently to the green ones and the yellow ones. And so as a result, we start to see these beautiful rainbows here, which is really, really cool. Now, even when they're made, the color they color differently under stress as well. So this can be used to identify, as I said, stresses and possible weak points in shapes. So as I said, with this little Petri dish here, if just looking at it, it looks completely see-through. But under the when we use the special glasses and also using our screen, we could see that there are certain areas where it is not perfectly designed. So we can have a look at that, and look, you can see that just at the top here that there are kind of stress lines here that you wouldn't normally see. Okay, fantastic, great, brilliant. So now, little poll for you guys. Let's just do a little poll. Polarization can be used to spot stresses in transparent objects. So this is a transparent object, okay? Is it true or false, okay, that polarization can be used to spot stresses, that's like changes of forces and things, Or is it that, is it false? Can they not? Or I don't know. I don't know. What do you think? Can we use it to spot stresses? Now I can see Ebne, you've put it into the chat there. Fantastic. Good. What do you guys think? Now I can see almost all of you guys have answered. Pretty much all of you now. Fantastic. 81% of people voted. What do you think? Do you think it's true or false? Can we use polarization? Can we use the fact that light travels these different angles to spot stresses and forces? Now 100% of you guys, everyone has answered. Let's have a look. So the results, 100% of you are absolutely correct. We can. Now, by the way, I'm not condescending you because I know I just said that we can use it for stresses. I'm not trying to make fun or anything like that. Just making sure that you're listening and you understand, and also a much better way of learning these things. Okay, let's get on to the third one, which is really fun. I enjoy this third one. Well done for everyone who answered. Now, most importantly, I didn't need you to get that right. It's mostly that you had a go. So thank you very much. And I just want to acknowledge you for having a go and having a go at clicking it. Fantastic. All right, brilliant. Okay, so hope you enjoyed that experiment. I quite like that one, actually, which is pretty cool. There's also some other things that you can put under there as well. So actually, just before I move on, I'm just going to quickly show you. Look at this. I've got this little test tube here, and look at that. You can actually see the sort of colors in the test tube there as I sort of rotate it. There's some wonderful, wonderful colors there that are coming through, which is really cool. I love those. Owlie especially loves them, don't you, Owlie? Yeah, buddy. Do you want to see? Owlie's going to hide behind the glasses there because he has to see as well. There we go, Owlie. What do you think? Can you see the colors? Yes, he says yes. Fantastic. All right, buddy. Perfect. Thank you very much. Okay, cool. So have a go at home and try some objects in your own home. Okay, so take objects. Now they need to be transparent, which is just a fancy way of saying they need to be see-through. You need to be able to see through them. But try different transparent objects. Remember, you need to be wearing your glasses. Okay, so I've put the glasses. I've actually taped the glasses to the camera here so that you could see as if you had the glasses. Great. All right, let's have a look at the polarized light mosaic. Okay. Now that's the third one. So we're going to have a look. Now there is a little demonstration at the back of the polarized light one here that essentially shows again a diagram with only certain light essentially only certain colors being allowed through these polarization filters. So please do have a look at that. All right, so we're going to be having a look at number 3 now. Again, now this is probably my favorite of the 3 because especially as the colors. But now, the thing about it is, remember I said that when you put an object under stress, okay, when you put an object, so you pull it or push it or twist it, okay, what usually happens is the atoms or the molecules that make up this object, if I pull there, they will actually get stretched so they go side to side, and they will only allow light in a certain direction through. Well, the same thing happens when you make sticky tape or scotch tape or sellotape or whatever you call it. So when we make sticky tape, especially the see-through type, okay, so this sticky tape here, okay, so what I'm going to do is, obviously I'm slightly out of focus there, but there we go. When they make it, it is pulled very, essentially it's pulled quite tight, which means that in general, the molecules do arrange themselves along the lengths of the tape, which means we can use it for some quite cool visual experiments. Perfect. Now, say hi to Owlie. And why doesn't glass have a color? Just press it. Yes, it's to do with the stresses and strains that the molecules are under. So as I said, try the things at home and you'll actually see that when they're constructed, certain objects are able to actually affect the polarization of light and other objects don't, which is actually really interesting. And again, if you want to go deeper into this, there's some great articles online, but essentially the main thing here is just to get that some objects will affect the polarization, the direction, the angle at which the light is traveling, and some don't. So well done for finding that glass doesn't. Excellent, excellent. Cool. What is Owlie's favorite experiment? Owlie, what is your favorite experiment from these ones? You quite like that one there. Yeah, okay, cool. Yeah, you like that one because of the pretty colors. But how about this one with the tape? You love that one too. So I think maybe it might be a joint if you had to pick one. This one we're about to do. Okay, all right. I had to pick one. There we go. Let's do it. So let's have a look at this one here. So molecules are stretched along the tape. Okay, so to change its color, you just need to rotate it. Okay, so let me just show you this. Here we go, I'll do it on the tabletop. So I've got the tape here, and I'm going to stretch this along. Now have a look at this. As I bring the tape up, look at this. You can start to see that the tape itself, look at that, it's dark there, but when it's sideways, we can actually see it. Now I've left the spoon sort of behind it. What I could do is I could put a colorful object. I've actually got a little water molecule here from my MEL chemistry sessions. So we go, I'll pop the water molecule there, 2 hydrogen and oxygen. And if I do it sideways, look at this, you can start to see the water molecule from behind. There we go. There we go. You can see the spoon and the water molecule there, which is pretty cool. So we just need to rotate the tape. Now we can actually do some fun, we can actually do some art using this. So what we need is this. So out of the set, okay, we've got some templates here. So let me just move this over to the side. We've got some templates here, and I think probably we can do any of these. But what we'll do is I'll start off with the kind of the grid one. So that is this one here. But I'll encourage you guys to do these yourselves at home. So what I'm going to do is just start with this grid one. Then what I do is I take one of these pieces of transparent film, okay, and what we'll do is I'm going to place that onto this template here, okay. Now, what color means the tape is under stress, as Alexander's asked? And I love that question. That's very good. Actually, it means it's under stress if there is any of this polarizing effect. Okay. So what should happen if the tape is not under stress at all is it should just look like this. But the fact that it actually allows some light through, look at that, you can actually see the, and if I hold this up here, my hands are below, but the fact that it allows any of that light through shows us that it is under stress, okay, which is pretty cool. All right, but as I say, I'll go into this a little bit more in just a second. So what I'm going to do is get my template. Great question. I love that you guys are asking questions. Yes, absolutely, Rez. Perfect. We are nearly done. So what I'm going to do is there are little clips here, little paper clips. And what we're going to do is we've only got a minute or so left to do this, but here we go. Let me just put this over here. I'm going to put one of the paper clips onto one side, and I'm going to put the paper clip onto the other. Now, I do encourage you guys to try this yourselves at home, but don't worry, I'm going to make sure you can see what you would expect to see. And I'm going to take the tape here, and I'm just going to cut that. And what I want to do is I want to cut it so it's about the width of the template here, okay? So look at this. I just take the tape and I'm going to place it across the template like this. I placed it, so what I've done is I placed it so it goes in line with this darker pink line. And then what I'm going to do is do the same with the rest of the tape. Okay, so what I'll do is now these I'm going to do is I'm going to just cut some lengths here to make it a little bit easier for myself just quickly. So I'll let you try these ones at home. So I'm just using the edge of my desk here just to make it a little bit easier for myself. And I want to cut 6 lengths essentially. Okay, so 6 little lengths that's each about as wide as the template there. And I've already done 1, so I just need to do these last ones. Now, just before we do this experiment, I'm going to ask you guys. Now, each week we've been trialing out sending you guys a postcard. So Owly and I, using MEL Science, we'll send them to them, and they will send it out for us. So, but if you would like to receive one of these special postcards from us, then please let us know at the end. Okay. Now, Rez has actually given a little link for you in the chat, where you can click and you can just fill it out. And I can see that Kira's saying, yes, please. And it's just a personalized session. We write them, each one for each session is completely unique. So we make sure, and we'll just put a little information. And mostly it's just a hello from Owly and I. I see Chelsea saying yes with exclamation mark. So please just type, all you have to do is click the link that's under in the chat there, the Google Doc form, and then let us know your information and where you would like it sent, and that is all done for it's all automated, so which is pretty fun. Right, now what I'm going to do is I'm going to take my pieces of tape here. I've already stuck one along here, so what I'm going to do is stick one along here, along the middle line, and then I'm sticking one along the line there. Okay, now it doesn't have to be perfect. And then what I'm going to do is stick one going up and down like this. Okay, and I'm going to stick one like this, up and down as well. And I could have made that a little bit longer. And one that goes up and down like this. Okay, so what I've got now is I've got my sort of tape stuck. I've got 6 pieces stuck like that. Now all I can do is I take off the back here. We can sort of see that there is tape there. Now watch this. What I'm going to do is I'm going to put this in front of the screen here. Okay, and I just bring this down. Now look at that. You can actually see this pretty pattern like this. Now what I've done is I've specially got the this molecule sort of behind it just so you can kind of see. But if I move that out the way, have a look at those pretty colors that you can see. There's some orangey kind of colors, and there we go. And part of it actually goes black there, which is very, very cool. So look at that. Really, really cool. And you can sort of see my hand kind of behind there as well. What are you seeing at home? What are you seeing color-wise? Now, obviously, that's one of them, which is pretty cool. It's just a sort of, you can actually see there's a little bit of polarization happening there just from my tabletop, which is pretty cool. Because remember, you're wearing the goggles here. Make sure you are wearing these goggles, okay? There we go. But there's also a template here where you can try them at different angles. So lay one piece of tape like this and then one piece of tape so it doubles over. And then the same thing here and diagonally. And the other thing you can do, which is quite a fun one, is you can create a wonderful, wonderful mosaic like this. So you can do lots of different directions. So all you have to then do is just take one of these and just lay them all over and have a look at the amazing colors that come out of that one. Have a look at the amazing, amazing colors. Now, I have to say that I can see that Levi and Layla saying blue, gold, fantastic. There are some really cool colors. Ali, what do you think? Which colors which ones have you been seeing? Yeah, which is pretty cool. Now, I have to say, if you actually look at the front of the polarization set, you can actually see the various objects. There's a cell phone case here and some goggles. In fact, actually, we've got our MEL Science safety goggles as well that we're going to try. And we've got our MEL Science chemistry set here. And we're going to try these out, which is really, really fun. Ali, are you up for doing some more? I know we've done it before, but he loves it. He loves, I have to say, this is an experiment he loves doing over and over again. Now, I hope you guys have enjoyed it. So remember, the first one was the magic trick, okay? We had this incredible magic trick where if you have it in front of each other, nothing happens, but the moment you rotate it, it goes dark, which is very, very cool. And then we looked at stresses and strains in objects, for example, like this plastic spoon, and also in the Petri dish, and we saw how you can actually use the colors to see the properties changing and how if you put stresses and things under there. Fantastic. What else did we do? And we got to use the sticky tape to create this, which doesn't look good at all. But the moment you use your goggles and also the screen, you get to see some pretty cool colors, don't you, Ali? Did you enjoy that? Best session ever. Wow, okay, I think this is quite extreme. Best session ever. He loves this session. Now I can see that Kira said we'll have a fabulous Zoom lesson with this for all the sets. Made a huge difference. Yeah, well, I'm glad that you've enjoyed this. Yes, the goal is that we should have them for all of the sets. So we'll obviously let you know. And if you have the sets, then yes, Ali and here we're here. We've also got Dan, who's a good friend of mine. He does a lot of the chemistry stuff. So I'll be doing a lot of the kind of physics and also the MEL kids as well. For you guys, it's been wonderful having you. Thank you, Kira. Fantastic. Dillard says he likes the teacher and especially Owly. Well, thank you very much. Owly says best session ever. So that's amazing. But I know you're biased though, Owly, because you like all the pretty colours, don't you? Yeah, he says that's legit. So that's fantastic. That's happy. Brilliant. Liam, thank you as well. I can see lots of thank yous. Winter says, I like how you teach. That's very nice of you. I think Owly thinks he's better, but that's fine. I think you probably are better, actually, Ali. Cool. Thank you, Levi and Leda, for being here. Aaron as well, thank you so much. And guys, thank you very much for your awesome questions. And I just want to acknowledge you for being here on a Saturday, live from London. It kind of makes it fun for us, doesn't it, doing this on a Saturday? We love this. So just want to acknowledge you for being here and wanting to learn about science and things like that and stuff. Ali says, I'm looking a little bit disheveled. Yes, okay, I will shave a little bit better for next session. But really lovely to see you guys. And Deekshith as well. Thank you for teaching. My pleasure. And love you, Ali, says Chelsea. I think, Ali, you have a bit of a fan club. Now, if you want to send us any pictures or any photographs or any videos of what you're doing, please use MEL Academy. Sorry, so MEL Academy at melscience.com. And Phoebe, John, and Wiseheart, I'm really glad you enjoyed it. Thank you so much. Yes, fan club, says Chelsea. Love you too, Ali, says Kira. Alexander's bio. I know we're going a minute over now, so thank you again for all your wonderful comments, guys. Lovely to see you, and we will see you again very, very soon. Take care, and yeah, goodbye.